We are recording. Hello, this is JavaScript Syracuse, Syracuse JavaScript Meetup. And on the agenda tonight, a couple things about Angular's comparison to React and Vue and Svelte, and all that talk will be at the end for front-end framework jibber jabber. Uh, Up first, we've got a Svelte JS, and to touch on that, we'll start with the premise that the creator has. Let's build a reactive front-end framework, and let's do it in a way that is novel. And that way is to use a compiler. So the code that you write is then compiled to JavaScript. That's what you ship. And you make optimizations to the code that you write. I'm going to show that as a very quick example of a edit to Svelte. When we talk about adding reactivity in any other framework, you start to think about dependencies in the RxJS style of dependency is one. So with that in mind, I'll share my screen and start on some Svelte. Let's close out of some Chrome Craft and get into some iTerm. All right. I've got this project checked out. It was started by James Patrick Gibson, a Syracuse Svelte master. And I am not that. I am a Svelte neophyte. And with this, I show you a git diff. What I'm going to show you is we've got this code here, which was deleted, and this code there was added. And this code up here was also added, which is called example and is referenced down here. So what this code is about let's have a look. So I'll run the Svelte dev server. It's a fast command that underlying it is a roll up. And let's check that out in Chrome and see the relevant challenge, the reason that commit exists. Here we have a preview of the settings for this box component. And as we adjust these controls on the side, we see this get updated. So as I go down, it changes the view over here and updates the code over there. Union here is a early stage design system for Svelte, and the documentation has to, for design system, for any component system, have niceties. This is a nicety, and currently it's broken. Let's go down to 0 on the point where anyone seeing this, they're seeing space 1, but over here we're at the position of 0. If I go to space 1, then it shows the position of 0. If I go back to 1, what's happening is it's always a step behind. So our view is out of alignment with our model. And another way to think about this is also, without thinking about a model, visually, we've got two places in the view that are not aligned. The control is at position 0, and the text is saying that the control is at position 4. We can fix that fast enough. And that's what that commit was about. So with a quick stash pop, everything is going to reload, and now everything's aligned. So what it is that we're talking about is that this right part of the state is an input, and the rest of the app reacts to it. And this is what we talk about when we talk about Svelte is forward reference programming is the inspiration. And that's to say, in a spreadsheet, you have a cell, and when you change it, there's a dependency graph underlying it that will update any of the cells that depend on it. Everybody's done formulas in Excel. So in front-end web, that forward reference programming is called reactive programming. And reactive programming is a way that we respond to inputs. So it's accomplished in a number of ways, in a number of different front-end frameworks. And in Svelte, they do it at compile time. So we see this $:, and this is valid JavaScript. You've never seen this, and I've never seen this until Svelte. And nobody uses it, and that's the point. It was chosen because it's so obscure. It's hard to have anything else. Uh, you won't mistake or be overriding anybody else's intention by using the $:. What this is doing in this context is signaling to the compiler that we would like to watch for updates to this element and then react to them. So by adding the $:, this element example becomes reactive. We then at the bottom, using this prison bit, we say that the source is going to be the element example. So when the things that it depends on change, it will change as well. So there you have reactivity. Don't sweat so hard the idea that there's this $:. Don't sweat so hard what's happening under the hood. And while it's a fascinating thing and you can learn more about it, the focus is just to say that without dependencies, we're adding reactivity. And the way it's doing that is by reorganizing and rewriting your code at compile time such that it can use a series of functions to implement forward referencing in JavaScript. It's a novel idea. Svelte is a novel idea. And there's no comparable, and there's no other implementation quite like it. It gives it certain advantages. It's also a little bit new, so it has some disadvantages to the other frameworks. So Svelte, it's nice. You add reactivity with a $: and a colon. You do other nice things with it that in detail can be covered. And let's hit the next topic. So I'm in Syracuse IO, going to go to the JavaScript channel and see what my comment was on the next topic. Now, Syracuse.io is able to be joined by anybody. It's a public Slack. You can go to Syracuse.io, the website, scroll down to the bottom, and join the Slack. So, making a decorator in TypeScript. Let's do it. And we'll go to the parent folder of this one. I'm going to make a new folder called Syracuse.js. And I'll do an npm init. Just call it all of the defaults. So there's a file. We'll make a new file called index.ts, and we'll make a new file called onchange.ts. So if I've got my self cool, here we go. I'm going to copy this decorator into that other project and talk to you all about it. This is the definition of an interface and the export of a type called a callback function. And here is a decorator. And what decorators do in TypeScript is annotate methods and classes and provide new functionality to them. So I'll define a class called, let's call it cat, simple enough. And cat can have a property called age, here's type number. That's enough for the moment for our cat. And we can do a console log on a, say, need a constructor here, don't we? Pass it number, this dot age is equal to that number. It's not called number, that's like that reserved keyword problem. Call it age like this. Say const tabby equals new cat. Give it this. As this setup goes, we're establishing that we have an age on a cat and using that as a way to talk about decorators and listening to changes on them. Here we go. We log our cat. It has the age of 2. I didn't botch anything. So I am not sharing my screen. I did all that typing. I can assure you that what you heard was typing. And here we are. Let's go forward and start to talk about a decorator. Going to say import from onChange. And we're going to import onChange. There it goes. Now we've got a decorator called onChange. Use it. Being used. We're going to say take the number, pass it a callback function that says, we'll just call it data. It's all right. And we're going to log that data. So at this point, we get a little error. It says that experimental support for decorators is a feature that's subject to change. Turn on the experimental to avoid that warning. Don't have a TS config. We're going to keep the warning. It is only a warning and move forward. So let's, after we've got our tabby defined, say that tabby dot age is equal to 3, 4, 5. We save that file. go to TS node, run it again, and we can see we've got a problem where it's really insistent. So initialize TS config. How can I generate it? Let's just do TSC init. That's always a good command to run. And now when I open up this project again, I've got that TS config. Find the decorator line, turn that on, run our TS node again to get past that error. We've got a implicit any. This is all TypeScript benefits, which we'll say is a number. Try this again. And let's see, symbol only refers to type, but it's being used as a value. Do you need to change your target library? Charge it to 2015 and later. Let's go to our target and we'll say ES2020. Let's try again. And we've got it. We've done our TS config and we've got 4 logs. So what does onChange appear to do? It appears to log when the age changes. That's exactly a reactive concept. When something changes, do something with it. And by using this decorator, we can apply this anywhere that we like. We could console log not only the age, but we can give it a name and we can say this is a string. I'm just going to copy this over here, take that and call that a string. The name is of type string. Let's always name this one equals kitty to start. And now that we have Tabby, let's give her a name and say it is in fact Tabby. And then let's rename Tabby to Toby and see again that we get our console logs. Initially it's Kitty, then Tabby, then Toby. The onChange, as it's defined here, has this strong typing ability where you can pass to your callback function the type that is a part of your class. This is something of a utility decorator. And let's look at how it gets defined. And the first part is what is strictly necessary for a decorator function is what we're returning here. And we have a function returning a function so that we can pass a callback to the decorator. So we're talking about a parameterized decorator here. You can also have decorators that do not have parameters. They just look like this. They just decorate your property. So we do that quick closure over it so that we can pass in a callback function for this specific decorator. What we're seeing here starting at line 22 is the general form of a decorator, which is that it takes a target as an argument and a key as an argument. And that target is something we can log out here. I can just quickly show you all that we got a target and a key. Let's have a look at what those are, and I will over here stop doing these console logs so that our console can be clean. So our target is a empty object and an age or a key is the name of what is being decorated. So remove the onChange, we only get the one log where we've got our empty object and our age. Let's initialize our age to be, say, 1. See, does that change anything? It does not. Continuing down, let's look at the usage of our target. Target.constructor.name. Okay. Down here, we do object.define property of the target, where in the define property, it first takes in the object, then the second is the property, and then finally our attributes. We here are, by decorating the object define property, defining that this set does a caching of changes and ultimately at the bottom calls whatever your callback was. So that is how we are using our callback, and then our get is just returning a cached value key. So that's basically saying that every time that we do a get on this object, just give us what its value is, but anytime we're doing a set on this object, let's initiate a callback function, and then we'll do something with it. The rest of it is all more nuance around how can we see if this change is the first change, or what is the previous value, what is the current value. Let's be about the next E2 ES2020 features that you can use today in Node. Check out my Node version. It is 14.13.1. Let's make a new file, say touch file.js, go to code, file.js, and let's say that we'd like to do something called option chaining. I don't know what's up with Google over there. Let's keep going. Option chaining. All right, so const x is equal to an empty object, and then we do console.log x.anything. So we can now run node file.js. Let me quickly back to the screen share. Pardon that. Here we go again. Const x, x.anything, node file.js, we get undefined. What if we do y.anything? What we get is an error, y is not defined. So how would we ordinarily handle this? We'd probably do y and y.anything. And then it says that y is not defined, reference error. And usually we can do something like const y is equal to null, and we'd be covering the same ground. And so const log y anything, and then property anything of y is, in this case, null. That's a curious thing. Let's try this out. Cannot read property anything of null. This is an all right thing to check for. Let's try to add a question mark. And now we get undefined, and that is option chaining. Option chaining prevents this error, cannot read property of null, cannot be property of undefined. Next up, we've got nullish coalescing. So what do we do about nullish coalescing? So it looks like this. Const x is equal to null. Let's say that we want const y to be equal to x, or like this, 0. And then console.log our y. So what do we get in our is 0 in the console? Change that to 10. What is it doing there? Let's say that const x wasn't 0. Let's say it was 1. Ah, now it's 1. What's happening in JavaScript a lot is that you can get a property that's null or undefined, and you're trying to evaluate against it. And both of them are falsy. So when you're evaluating against something that's null or undefined or 0 or empty string, they're all going to return a false all the time. That's not always desirable. Say you are also using the idea that a object or a variable is meant to be a number. It's meant to be something that we do math on. If we, instead of wanting to console log, say we wanted to do plus 10, and we had it where x is equal to null, then we said y is equal to x. So basically we're just trying to do here null plus 10. We expect y always to be a number. In this case, x is not defined, so y is not a number. And what we get is 10. We got some correct-ish sort of answer. But with undefined, it's not a number. So what we can do in this case is say, if x is null or undefined, make it equal to 0. That's nullish coalescing. Next up, out of the talk topics, is ES modules in Node 14. Let's get into that for a moment. So I'm here in file.js. I'm going to go over to this, and I'm going to npm install something called Airtable. It might be Airtable.js, I'm not sure. npm Airtable. That's the add on it. Let's see what we got. Looks like that's probably what it is. Install Airtable. All right, so let's use this and say const Airtable is equal to require Airtable. This is mostly how modules work in Node. Is you require them in, and then you run node your file, and then you don't have any problems. Yet I was in Typescript, and I was doing something like import Airtable from Airtable, or something similar to that. Let's try that in Node. And now we have cannot use import statement outside a module. So let's go to package JSON, and let's say a module, and let's talk about the properties. What are they? Module. Node 14 module. We're going to see that there is something called ECMAScript modules. And with ECMAScript modules, we are going to include in our package JSON a type field called module in order to turn them on. So go like this, type module, let's run node file, and that error is gone. So ECMAScript modules are native to the programming language modules. Node has them on. Some of the latest browsers allow for them as well. And I'll stop sharing my screen. There's not much more to see. We've had modules in JavaScript and we've all used CommonJS, but these have all been built by developers because there's no default import statement that the programming language provides. Node 14 has import statements now, and for the idea that you can do this natively, that's a major improvement over needing to do Babel or TypeScript compiling or anything similar. It's all native. That's the future of modules. And that's just about the end of the content. So cheers. Have a good night.